Hi, now we're going to go through the tutorial 1 questions that we reviewed in class. So the first question is about 1's complement, and for us to better understand, find extension for the integer part as well as fractional part. So if I see the first question here, 0101.11, and the second number is 010.0101. Okay, so what I need to do is, in order for me to do any form of subtraction or addition, I need to first do the matching of both the integer part and fractional part of in terms of number of bits. So in this case, you can see that in terms of the integer part, okay, the first number has 4 bits, second number has only 3 bits. So I need to add one more 0 in front here, and that is called your integer part find extension. Okay. So if the most significant bit is 0, then I extend and make it a 0 over here. Okay. Now, the next thing that I need to do is I need to do the same thing for the fractional part. In the fractional part, you don't need to worry about the last bit. You just make sure you add zeros to make sure the number of bits are the same. So the second number has 4 bits, the first number has 2 bits, so I add 2 zeros here. Okay, so that is the first step. Okay, so the first number is extended, okay, and to look like this, and the second number is extended to look like this. Now, what we are trying to do is a subtract operation, and as you have seen in the lecture, the addition plus multiplied by minus is equal to minus. So that means, in order to do a subtraction, I need to do the addition of the negated value. Okay, and how I do this is I must do the complement. Okay, so the second number here I must do the complement. So let me do the complement over here. So after I do the complement of this second number, I get 1101.1010. Okay, so this is after I do the complement. Okay, so now I have both the numbers. Now let's rewrite them a bit neatly so that you can see it. Okay, so the first number is this 0101.1100, and I'm going to plus with the complement of the second number. So the complement of the second number is 1101.1010. Okay, and that gives me so 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0, carry 1. Let me put the decimal point here. The 1 plus 1 plus 1 is 1, carry 1. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. And 1 plus 1 is 0. And then there is one more, carry 1 here. Okay, so in 1's complement, whenever you have a final carry out, that carry out must be added back in. Okay. So I need to complete this carry in again. So this this carry out must be added back in. So 0 plus 1 is 1, 1, 0 dot 1, 1, 0. Okay. So that is the final answer for your part A here. Okay. So that is the final value you get. Okay. Now let's go on. Of course, if you want to verify it, you can of course go ahead to check out in terms of the actual decimal value for this and the fractional value of this. Okay, so that I leave it to you to do. Let's go on to the part B. Question 1 part B. In question 1 part B, again the same thing. The first step is write out the two numbers and make sure the integer part and fractional parts match. Okay, so 111.101, and the second number is let me write from here 010.1110.11. Okay, so it's easier to see the difference. Okay, so what I need to do is I need to add one more bit here, okay, and add one more bit here. Okay, now there is a match. Okay, and I'm currently doing this first number subtract this number. Alright, so what I need to do is I need to go and do the complement operation. Okay, so if I do the complement operation, I get 1000101.001. Okay, so once I've done the complement, then I can rewrite both the numbers. Okay, so let me rewrite both the numbers over here. So 0010111.101. That is the first number. Okay, and I'm going to subtract. Okay, so since I've already done the complement, like I said, I'm adding the complement of the second number. So that is 1000101. Okay, so let's do this addition. 1 plus 1 is 0, carry 1. This is 1, this is 1. 1 plus 1 is 0, carry 1. Same thing here. Plus 1 is 0, carry 1. This is 1, carry 1. 1, 1, 0, and 1. Okay, so in this case, there is no carry out. Okay, that is your answer. Okay, how do I interpret this answer? So it is important when you're dealing with complements to always look at the most significant bit of your final answer here. In our part A, okay, the most significant bits of the final answer was a 0. Okay, so this indicates that it's a positive number. So in a positive number, I don't need to do any other additional step. I can directly interpret the integer part, okay, in to the power 0 times 1, to the power 1 times 1, and so on. And I can also interpret the fractional part, to the power minus 1, minus 2, and so on. But for negative numbers, okay, because the most significant bit is 1, so this indicates that this is a negative number. I cannot directly interpret this bits in to the power of 0, 1, 2, and 3. Okay, what I need to do is I need to do one more additional step, okay, which is the complement. Why do I need to do it? Okay, as you have seen here, whenever the most significant bit is a 1, that means I'm actually dealing with the complement of the actual value. Alright, so this answer is also having a most significant bit of 1, which means that it is the complement of the actual value. Okay, the 1 tells us that it's a negative representation. So to get the actual value, I need to flip or complement the bits one more time. Okay, so I need to do one more round of a complement. Okay, so if I flip all the bits again, what do I get? I get 0, 1, 0, 0, 0, 1, 1, dot 0, 0, 1. Okay, so that is the final answer. Okay, and after I get this answer, I can of course figure out the integer part of it and the fractional part of it. Okay, and the final answer, important thing is now I must put a negative in front of it. Okay, so that is the way you interpret the final answer. So you need to look at the most significant bit as whether it is 1 or 0. Okay, so for the integer part of this, you will get as 35. Okay, you get as 35, and the fractional part of this will be 125. Okay, and since the most significant bit was a 1, you need to put a negative sign in front here. Okay, so that is your question 1. Okay, hope it's clear. Now let's look at question 2. Okay, in question 2, we are asked to represent the decimal value, okay, in this IEEE single precision representation. Okay, and give the answer in hexadecimal. Okay, so the first thing is, okay, so the number that we are given is this, negative 0.078125. Okay, to represent this in IEEE 754 format, what I first need to do is, I need to convert from the base 10, I need to convert it to something in base 2. Okay, that means I need to find the binary representation. Okay, the negative that you see here, you don't need to worry about it. So the first step you need to do is convert to binary. Okay, you can don't need to be concerned about the negative sign. So let's do the first step. So 0.078125. To convert a fractional part to binary, I need to do repeated multiplication by 2. Okay, so I multiply by 2, I get 0.15625. Okay, and what do I need to do? I need to keep track of the integer part here. Okay, so if the integer part is 0, then I keep track of the 0 here. Then I repeat the process again, 0.15625. 0.25 times 2, I get 0.3125. Okay, so again this is 0, so I keep a 0 here. Then 0.3125 times 2, I get 0.625. Okay, so again 0 here, 0. Okay, 0.625 times 2, I get 1.25. Okay, so whenever I get a 1, I must make sure that the next multiplication I discard the 1. Okay, so I just write 0.25 times 2, I get 0.5. Okay, so the 0 is here, and 0, sorry, okay, 0.5 times 2, I get 1.0. Okay, so it's 1. Okay, so the last ending is 1. Okay, so the first integer part that we got, that is your most significant bit, and this is your least significant bit. Okay, so now that I have it in my binary form, let's write it out. Okay, so this, okay, now we have an answer for it, and that answer is negative 0.000101, okay, to the base 2. Okay, now I can do the next step. Okay, the next step is, since the most significant, since the sign is a negative, the IEEE format says that the first bit will be a 1. Okay, so the first bit in the IEEE 754 format is the sign bit. Okay, so that is a 1 since the answer is negative. The next step I need to do is I need to normalize. Normalize means I need to convert this number into something that looks like 1 point something. Okay, so I need to convert the base 2 number to look as 1 point something. So how do I do that? That means I need to shift the decimal place around. So this decimal place I need to shift by 1, 2, 3, 4. Okay, so when I shift by 4 places, what do I get? I get 1.01 multiplied by 2 to the power of minus 4. Okay, why minus 4? Because I shift to the right. When I shift to the right, it is to the minus power. If I shift to the left, it's to the positive power. Okay, so that is your normalized form. Okay, now once I get the normalized form, okay, the next step is looking at whatever is after the decimal point. So whatever is after the decimal point, this forms the mantissa. Okay, so the mantissa, okay, is total of 23 bits. Okay, total of 23 bits here. And here I have 2 bits here, 0, 1. Okay, and what I need to do is I just write the mantissa as 0, 1 over here. Okay, and everything else will be 0 all the way. Okay, now the last part is the exponent. Okay, the exponent, which is 8 bits here. Okay, and how do I get the exponent? The formula basically says that I look at the power over here, and I follow this rule to say the exponent minus 127 equals to the power that I see here. That means the exponent is equals to 127 minus 4, which is 123. Okay, and 123 represented in a binary form is 0111 1011. Okay, so that gives you your final answer. Okay, so let me write it in a continuous format here. So 1 0 1 1 1 1 0 1 1 0 1 0 0 0 0 all the way until it ends. Okay, the question asked us to represent it in hexadecimal format. Okay, so what I need to do is I need to group it in bits of 4. Okay, so I draw a line here, I draw a line here, I draw a line here, and so on. Okay, the rest are all 0. So this is in hexadecimal is B, this is D, okay, this is A, and the rest is all zeros. 0 0. Okay, so that is base 16. So that is your final answer for question 2. Okay, so I hope it is clear. It is exactly the same process that we followed in the lecture slides. Okay. Okay, now let's go on to the last question here. I will not cover question 3 because question 3 the code is already given fully in the tutorial answer handout. Okay, so that should be quite clear in the explanation. Okay, so this question 4 is about reviewing pointers, okay, and integers. So let's go through this line by line. So the first instruction here is B pointing to A. So we have a variable A, okay, variable A, okay, and we now say that the data inside A is 3, okay, and another pointer B, okay, is now going to point to A. Okay, that is the first line. The second line, we say asterisk B equals to 5. So whatever B is pointing to will become 5. So B is pointing to A, so this one will become 5. Okay, that's the second line. In the third line, we have a variable C. Okay, so let me draw a new variable here, C. And C is going to have a value of asterisk B multiplied by 3. That means whatever B is pointing to, okay, whatever B is pointing to multiply by 3. So B is pointing to A. So let me write ampersand A here. Okay, so B is pointing to A. So A multiplied by 3 put into C. Okay, so I get a value of 15 inside here. Okay. The next line, I say D equals to B. D is another pointer. Okay, D is equal to another pointer. So if B is pointing to A, then D is also pointing to A. Okay, so when you assign one pointer to another pointer, basically they are both going to be pointing to the same variable. Okay, and then I have another variable called E. And the next line E, the next line here says E is equals to asterisk B plus C. So whatever B is pointing to, okay, plus C. So 5 plus 15 put into E. So I get a value of 20 over here. Okay. The next line says asterisk D equals to C plus E. So D is also pointing to A. So it's equals to C plus E. So C plus E. So 15 plus 20 is 35. So now I'll put a value of 35 inside here. Okay. In the next line, I'm going to say F is equals to E. So F is another pointer. And F is now going to point to E. Okay, the next line here, A is equals to asterisk F plus asterisk B. Okay, so A is equals to whatever F is pointing to. Okay, so F is pointing to E, and whatever add with whatever B is pointing to. Okay, so A and E. So 35 plus 20 put back into A. So eventually A has a value of 55. Okay, and the last instruction here, asterisk F equals to asterisk D minus asterisk B, and both B and D are pointing to the same place, so 55 minus 55 is 0, put back into whatever F is pointing to. So here I get 0. Okay, so that kind of gives you the final answer. So A is 55, C is 15, and E is 0. Okay, so this is just a question to help us recap the concepts of pointers and variables. Okay, so that brings us to the end of the tutorial. Okay, hope this has helped you to enhance your understanding of the questions we